Welcome to the video of our patented CBM pump. After the video, if you have any questions, we will be happy to answer any you have. Please contact UPC Global for more information. The CBM pump was designed initially to combat the coal bed gas production to rid the well of water so the gas would flow freely. The problems encountered when ridding the water was that the conventional downhole soccer rod pump would lock up and form a containment or gas lock. The breakdown of the CBM pump is fairly basic. There are only three moving parts to the pump. There are the piston, the lower standing valve ball, and the upper standing valve ball. The seating assembly can be either an API standard mechanical or cup type. The lower standing valve cage is a standard steel cage or non-corrosive material that screws into the lower chamber. The lower chamber, which houses the upper standing valve cage, is designed to allow maximum flow of fluid. Also, the cage comes with a carbide ball and seat for longevity. Attached to both upper and lower chamber is the relief connector or bottom discharge coupling. It is designed for the flow of fluid around the exit hole to the upper chamber, then back again to exit out into the tubing. As the fluid exits the bottom, it cleans above the seating mechanism so that if the pump is down for an extended period of time, the first stroke will clean the solid off the seating attachment. The upper chamber is where fluid accumulates on the upstroke of the piston. The length of the mechanism is determined by the stroke of the unit being used. The barrel is specially designed to self-clean. The top portion has a beveled end that acts as a wiper. It is only 2 feet long, which keeps the cost of repairs low. The piston is a spray metal precision ground to a tolerance of 0.02 of an inch, less than the ID of the barrel. On the upstroke, the lower standing valve opens and fluid enters the lower chamber and flows around the bottom discharge coupling, then enters the upper chamber. On the downstroke, the pressure from the piston forces the lower valve to close and opens the upper valve. Fluid flows through the valve and exits the discharge coupling up around the pump and out the top of the well. By exiting the bottom, the fluid will keep the pump from sanding in the tubing. There is less space between valves for gas to accumulate, and this prevents gas locking. As you can see on each complete stroke of the unit, the bevel on top of the barrel will clean the piston, as the piston is always occupying the barrel. There is nowhere for the solids to accumulate. The pump has proven itself all over the world, from Trinidad to China. Thank you for watching this video. Please let us know if we can be of any help.